Side-side-side similarity theorem. If the corresponding side lengths of two triangles are proportional, then the two triangles are similar. So let's look at these two triangles and let's label them. We are going to label the first one A, B, C, and the second one D, E, F. Now, the first thing that we want to do is set up a similarity statement. To do that, we would say AB would have to be similar to DE. Then we would say that BC is similar to EF. And finally, we would say that AC is similar to DF. If all of those were true, then we could say that triangle ABC is similar to triangle DEF. Now let's try one. So the first one we have, ABC, we're trying to find out if it is similar to HGF. So let's look at our sides. So first we have AC, which is corresponding to HF. So AC to HF, that's 84 to 14. Now, the next set we have is AB corresponds to HG, and that is 72 over 12. And we're looking to find out if these are in fact equal. Finally, we have BC compared to GF, or corresponding to, and so that would be 48 over 8. Now we simplify these. If these simplify, then they would in fact be similar. So if we simplify 14 goes into 14 one time, 14 goes into 84 6 times. 12 goes into 12 one time, 12 goes into 72 6 times. So those two are the same, which means those two are similar. Let's check the third. The third, 8 goes into 8 one time, 8 goes into 48 6 times. So yes, they are in fact similar. So we can say yes by side, side, side. And then we can say that triangle ABC is similar to triangle HGF. Now let's look at another one. So on the next one, we look at what corresponds to what. So first we have 52 with this one and this one that we're looking at. And so we say 52 over 28. Then we can look at, and if you notice the next two are the same, we have 40 and 16, 40 and 16. So it doesn't matter which two sides we're trying to set up. Now in the next one, we're going to look at what goes into what. The smallest number that goes into both 52 and 28, the largest number that goes into both 52 and 28 is 4. That goes in 13 times. That goes in 7 times. Now, the largest number that goes into both 16 and 40 is 8. So it goes into 45 times, 16 2 times. This one is the same as the last one, 5 and 2. But if you notice, these are not all the same. Because of that, we can say not similar, because sides are not proportional. Now, when we look at this problem, what we're trying to do is use proportions that we went over again at the beginning of this section in order to find the value of x that will make these two triangles similar. So we've got to figure out what sides correspond. So we have 132 that corresponds to 36. Those are the longest sides. Now, if you notice, we have 11x plus 11. That's one we want to work with. We definitely want that one there, because if we don't have it, we won't be able to find x. So 132 on top on one side and 11x plus 11 on the other side. Underneath 132 is 36 because they correspond. So now we have to look and see which side corresponds with 11x plus 11. Now, if you notice, 77 is on the shorter side, 11x plus 11 is on the longer side. Well, when we look at these two legs over here, 21 is the shorter side, leaving 30 to be on the longer side. So now we're going to use 30 underneath 11x plus 11. And we're going to, first and foremost, we're going to simplify this. These numbers are much bigger than I want them to be, so let's simplify. The biggest number that will go into both, or the greatest common factor, is going to be 12. So let's say 12 goes into 132 11 times. 12 goes into 36 3 times. So now we can use 11 over 3 equals 11x plus 11 over 30. Now we can cross multiply. 11 times 30 is going to give me 330 equals 3 multiplied by 11x plus 11. Now, we can distribute that out, or we can go ahead and divide. I prefer to go ahead and divide, gets my bigger number smaller. So we're going to divide this whole thing by 3, and this by 3. This cancels, leaving me with 110 equals 11x plus 11. We're going to subtract 11. 11x equals 99. That will give us x equals 9. So x equals 9 is our final answer. Now, pause the video and work on the next problem. In this next problem, we have a lot of information going on. So we have to choose what information we're going to work with. Now, first and foremost, we want to know the value of x in this problem. So that means we have to use this one. That is a side length of the inner triangle. So if we're going to compare this one, we're probably going to use this one as well. Next, we want the hypotenuse of the two triangles. Now, we just need to put together which ones we use when. So, what we'll do is we will say biggest number on top, 64, is compared to -4 plus 4x equals. And then, because we went with the biggest number on top, we've got to go with the biggest number on top again, or the corresponding triangle, using this large triangle, small triangle. So large triangle on top, small triangle on bottom. Now we can cross multiply. But let's go ahead and simplify first. We can simplify 96 and 36. The number that goes into that, or the greatest common factor, is going to be 12. But 96 is divided by 12 8 times. 36 divided by 12 3 times. And then we can also simplify over on the other side. That's not something we do often. It doesn't present itself as often as we would like, but we know that 4 will go into both the 4's on bottom, 1 time each, so that will give us -1 plus x, and 64 divided by 4 is going to be 16. So now we can take this value and these values and make a new proportion. 16 over -1 plus x equals 8 over 3. Now we can cross multiply. 3 times 16 is 48. 8 times, we can say 8 times -1 plus x. We're going to distribute our 8 out. That's the other way that we can do this. We can still divide by 8 right now and avoid the whole distributing completely, but let's go ahead and distribute so we can see how to do it. 8 times -1 is -8, plus 8 times x is 8x, equals 48. So now we can add 8. That's going to give us 8x equals 56. Divide by 8. X equals 7. Moving on to the side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides including these angles are proportional, then the two triangles are similar. Now, what we're saying is that if we have triangle ABC and we have triangles DEF, and I tell you that angle A is congruent to angle D, so we write that the measure of angle A is congruent to the measure of angle D. And then we say that this side is 2 and this side is 3. So 2 and 3 are our up numbers for our bigger triangle. And then our numbers for our smaller triangle are 1 and 1.5. So 1 and 1.5. If you notice, both of these simplify down to 2. So that would tell us that AC is similar to DF and AB is similar to DE. Now by doing this, this shows us that we have three things. We have a side, an angle, and another side. So a side, an angle, and another side that are, the angles are congruent and the sides are proportional. Now let's do A. In A, we are attempting to determine if the triangles are similar. If they're similar, we have to write a similarity statement, and we have to explain our answer either way. So let's look at A first. We have two triangles. We're looking at what is similar. Now, it's already marked for us that angle U and angle F are congruent. So let's list that. Angle U is congruent to angle F. Now, the next thing we have to do is we have to determine if these two triangles are proportional. Remember, if they're proportional, we can cross multiply and the numbers will be the same, or we can simplify and the fractions will be the same. So what we have to do is we have to set up our proportion. We're going to have two ratios, 9 and 21. So 9 to 21 equals 18 to 42. So now what we're going to do is we're actually going to just simplify these. 9 can be divided by 3, and so can 21. So 9 divided by 3 is 3. 21 divided by 3 is 7. So on this side, we have 3 over 7. Now, on our other side, we have 18 and 42. Both of those numbers can be divided by 6. So 18 divided by 6 is 3. 42 divided by 6 is 7. We now have 2 exactly the same fractions, which makes them equal. So that tells us that our answer is yes, my triangles are similar by side, angle, side. And I have triangle WUV, which is similar to triangle HFG. And we have side, angle, side. Pause the video, go do the next problem, and then we'll go over it together. Now let's look at our next pair of triangles. We are going to make this bigger. And we have 2 angles. We can automatically see right off the bat, right here, this angle and this angle are congruent to each other. And we know that that angle MVL is congruent to angle TVU, and the reason that they are is because they're vertical. We've watched that and watched that and watched that, so we know that they're vertical. Now, if you notice that by the shape of these triangles, L is going to correspond with U, and M is going to correspond with T. So let's go set up our proportion so that we can figure out if these sides are proportional. So we have 8 is to 28 as 14 is to 49. Now, we are going to go ahead and simplify these because they can be. You can't always simplify these, but when you can, it's easier to do that than it is to cross multiply because you get into bigger numbers. So we will simplify when we can, cross multiply when we can't. 8 does not go into 28, so what goes into both? 4. So let's look. 4 goes into 8 2 times. 4 goes into 28 7 times. So our new ratio is 2 over 7. Now, what numbers go into 14 and 49? First thing we do is see if 14 goes into 49, which it does not. However, we know 14 only has 2 factors other than one in itself, and that is 2 and 7. So both of those go into 14, but only 7 goes into 49. So 7 goes into 14 2 times. 7 goes into 49 7 times. 2 over 7. Now, these are the same, so we can say yes by side, angle, side. And then our similarity statement is that triangle MVL is similar to triangle TVU. Our next slide asks, what are the 3 ways to prove triangles similar? Now, we've talked about all 3, and let's look at them now. The very first one is angle, angle. So we are going to look that we have 2 angles that are congruent to each other. Because if 2 angles on one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Now, on the next one, we're looking at side, side, side. So side, side, side. Side, 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 if we have A, B, and C, D, E, and F, we would say that AB is similar to DE, and AC is similar to DF, and CB is similar to FE. Then we look at the reason. Side, side, side states if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. And then finally, we have side angle side. Side angle side is our final reason, and let's label this Q, R, and S, and then X, Y, Z. And we could say that angle Q and angle X are congruent. And we could also say that side QR corresponds with XY, or is a ratio, and QS is proportional with XZ. So we have XZ, which is this line, and XY, and these two sides are proportional. So that gives us, and we'll make a note, side, angle, side. They correspond. When you have a pair in both triangles, you have to have both triangles there, then you can say that if an angle in one triangle is congruent to an angle of another triangle and the included sides are proportional, then the triangles are similar.